What's up guys, and welcome to this video walkthrough of the 2018 IEB mathematics exam. This is the November final exam. And this is going to be the first video. I want to skip over and move to question 3 just because I've done a quick run of all the questions and this is quite a simple question. So it says, so we're doing question 3. Okay, so it says given that f of x is equal to x squared minus 3x minus 4 and g of x is equal to x plus 1, calculate the following. Okay, so we want to calculate x if 1 over f of x times g of x is undefined. Okay, so remember, for undefined, the denominator, that's the bottom of the equation, the denominator must be equal to 0. Okay, so what we do is we're going to say that for undefined, so we can say this is question A1. So for undefined, okay, f of x times g of x must be equal to 0. Okay, and we know that f of x is x squared minus 3x minus 4. So we can say therefore, and then x plus 1 is equal to 0. Okay, so we can try factorize this a bit more. So what's going to work here? We can say that that's going to be x minus 4, because we want to get that minus 4, and x plus 1 to get that minus 3. Okay, so the quick check, x times x is x squared, minus 4x plus x is minus 3x, and minus 4 times 1 is minus 4. Okay, so we have that correct, times x plus 1 must equal 0. Therefore, we can say that x is equal to 4, or x is equal to minus 1, and x is equal to minus 1, but that's the same thing. So we're left with 2 solutions. Okay, and we get 4 marks for that, which is quite generous. Okay, and then we want to solve for x if f of x is less than or equal to 0. So for part 2, we say that f of x must be less than or equal to 0. So we know that f of x, I'm just going to put the simplified version, which was x minus 4, x plus 1, because that we already did over here, must be less than equal to 0. Okay, so now what we can do is do a quick number line where we have the values of minus 1 and positive 4, so the opposite signs as the brackets. Okay, those are critical values, so we can say critical values are minus 1 and 4. Okay, now what we do is we plug in a number much bigger than 4, than 4. Let's say we plug in 100. So if we plug in 100, that's going to be 100 minus 4, which is a positive number, times 100 plus 1, which is a positive number again. So we're left with a positive sign. Okay, now let's pick a different number between minus 1 and 4. The easiest number would be to pick 0. So let's pick 0. So 0 minus 4 is a minus, and 0 plus 1 is a positive. A minus times a positive is a minus. And then we pick a number much smaller than minus 1. So let's say minus 100. If we pick minus 100, that is going to be a minus, and that is going to be a minus. Minus times a minus is a positive. So now what we look at is our signs. And if we look at our signs, we're looking for less than or equal to, and that would be in this range right here. So that means, therefore, x is between minus 1 and 4. Okay, cool stuff. And we get ourselves 4 marks again, quite generous. Okay, so part B says, consider the equation the square root of x plus 4 minus 3 is equal to x. Okay, and it says, part 1 says, show without solving the equation that x must be greater than or equal to minus 4. Okay, so let's do part B here. And we know that the equation is the square root of x plus 4 minus 3 is equal to x. Okay, remember that anything under a square root sign must be positive. So anything under this must be positive because we can't take the square root of a negative number. Okay, so what we can say is, therefore, because of the square root, okay, everything underneath the square root must be greater than 0, so x plus 4 must be greater than 0, therefore, greater than or equal to 0, therefore x must be greater than or equal to minus 4. Okay, so that's our one criteria or condition. Okay, and then what we can do is it says solve for x correct to one decimal place. Okay, so now we're going to solve for x. So what we're going to do is we're going to start off, so this is part 1, and this is part 2. Okay, so we have to solve this equation. So we start off with the equation as it is. Okay, so I want to get rid of the square root sign, so what I'm going to do is I'm going to leave that on one side, and I'm going to take the 3 to the other side. Okay, the way you get rid of a square root sign is by squaring it. So what I do to the left hand side, I have to do to the right hand side. So then I'm left with x plus 4 is equal to, that's going to be x squared plus 6x plus 9. Okay, then I'm going to move everything to the right hand side of the equation. So I'm going to say that x squared, and I'm going to take this x across, so that's plus 5x. Okay, and then I'm going to take this 4 across, so that becomes 9 minus 4, which is plus 5, is equal to 0. Okay, and at this point, I'm going to say that we can't factorize this easily, so what we're going to do is use the quadratic equation. And the quadratic equation says that x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. Okay, and then I'm going to plug in a equals 1, b equals 5, c equals 5. Okay, that corresponds to the constants. There's an invisible 1 there, right? And then when I plug this into my equation, I get the solutions x is roughly equal to minus 1 comma 4, or x is roughly equal to minus 3 comma 6. Okay, and using that above criteria, I already know that x must be greater than minus 4. Okay, so basically what we can say is that both the solutions are valid, because if I substitute minus 3.6 in, that still works, so therefore both of these solutions are valid. If I plug in minus 1.4 into this square root, that still works. If I plug in minus 3.6 into that equation, that still works. So we are done at that point, and we get ourselves 6 marks. Okay, cool stuff, guys. I hope you found this video useful, and thanks for watching.